Hi, welcome to another lecture on business mathematics. Today's topic is function notation. So that famous y is equal to f of x. That's what we are going to explain today and learn how to play with this new Toya bars. Now, before we get into mathematical detail, let me warn ahead of time that this notation is going to be a source of confusion. To explain that, let me take you back to something that you are very familiar with. Uh, if I ask you, what is this? Majority of you are going to say, well, that's LOL, laughing out loud. That's what it is. Well, could it be something else? Perhaps it's something else. Here's another interpretation of the same symbol. These are two hands and head of a person sticking out of water and looking for help. So this is a warning sign for if you see somebody in that situation, call 911. You notice that these two don't have anything to do with each other. Laughing out loud and somebody drowning, that wouldn't happen in the same sentence. But just looking at that, you cannot tell what is it that you're looking at. And that's a problem of symbolism. Humanity always deals with this issue of creating a symbol somewhere, and something like that somewhere else means something entirely different. When it comes to function notation, we have the same issue. The problem is that somewhere in middle school you learn some symbol that looks mightily like this one, and then you're going to confuse this with the other one. So function notation might be new to you, and then you need to practice, and from the context you should be able to tell if you're dealing with LOL or you're dealing with somebody drowning. So let's go ahead and try to explain the function notation and see where does that come from. Suppose you are working in human resources department of some school, high school or something, and you want to write down people's teachers' salaries. Well, the salaries depend on many things. Say you are concentrating on number of years of experience. So you might say salary of a teacher with, say, 10 years of experience is something. I don't know, maybe $25,000. Well, that looks very little. Let's change that to something respectable. Let's say $45,000, okay? So I changed my mind. $45,000. Well, it took a line to write that down, and if you have a lot of references to something like this in a report that you're writing this whole sentence every time is not going to be fun to write or to read. So you abbreviate in the context of what you're doing. So you're having a salary, so you pick the letter S here. So S stands for salary. The main piece of information that you have here is somebody with 10 years of experience as opposed to somebody with, say, 20 years of experience and so on. Suppose all the other credentials are all the same. So you want to say the salary of a person with 10 years of experience. You write it S of 10 is equal to $45,000. Okay, so we abbreviated this whole statement to something shorter that we can write with few symbols, and then we can abbreviate it and talk about it. So if I write S of, say, 20, let's give some good promotion to this person. Let's say $65,000 and so on. So in this context, what are these things? So S is name of our function. We typically try to use the name so that it makes some sense to us. So S for salary makes sense. Mathematical functions are all generic. They are not related to anything, and they don't need to be related to anything. So these letters Y and X that you see here, they were kind of a fixation of mathematicians since the time of French mathematician by name of Descartes. He just popularized this idea of let's use the letters at the end of the alphabet for our variables and so on. And perhaps the historical reason the letter X is so famous is because of some issues in some translation that happened around the time of Renaissance. Anyway, so it's as a matter of tradition, the mathematicians are so much in love with X and Y. They could, of course, you choose your letters however you are comfortable with the situation and can help you memorize something. So what is this? That's the number of years of experience. So this is, you can write Y, but let me avoid that. Let's just, for experience, maybe I write E. And this is the monetary amount that the person is making. That is the salary of this person. Now, there is one thing that we need to bring in, perhaps to help us to avoid the confusion. For a while, I'm going to try to also write this word of in the context of the functions that we are writing, and then gradually we are going to outgrow that and drop that as well. Now let's go to some mathematical functions. So let's go outside of this example to things that are more mathematical. So if I write Y is equal to f of x, so these are now all generic things. X is something, Y is some number, X is some number, f is the name of a function. And then we write an example. So for example, if I want to write something that matches this type of numbers, I will have some function that's going to be increasing with time. As you have more experience, you earn higher salaries and so on. But in order not to deal with some strange large numbers and such, I'll just make up some fictional examples where our numbers are small. So it could be like 2x plus 3 or anything. So if you wish to think about it, you can think about x as the number of years of experience and say this is some salary some person is making, and the name of that output is x. It's customary to give some friendly name to these things. So x is sometimes referred to as the input. So it's like the name of this 10 would be the number of years of experience that the person is having. So that's the input. And what we are getting, of course, out of this thing is going to be, this is going to be our output. The name of the output is y. This is the output itself. This is the name of the output. This f is just the name of the function. So the f here is just like that s that stood for salary of something. Here is just a generic example. F of x is 2x plus 3. Let's go ahead, practice this thing a little bit and see how do we play with this thing. If this is given to me that I have a function f of x which is equal to 2x plus 3, then what is f of, say, 5? Well, this is input that is telling us some piece of information, and f tells us what to do with that information. F tells us take that input. So if you were to write this thing in words, you have the input number, so x is the input. Next stage is double your input. So this expression here means first you double the input. We have to understand that the multiplication happens first. Then this one happens next. After that, we say add 3. Whatever x is, double it, and then add 3 at the end of it. So I'll have 5 coming in, that's my input. First I have to double it according to this, so that becomes 10. So I have 2 times 5 plus 3. And the important thing is to realize that this happens first. This is 10, and then I add 3 to it, becomes 13, as opposed to what? As opposed to adding these two first, which we know that the multiplication comes first in mathematics. So 2 times 5 plus 3, that is 13. Let's do another one. Suppose I ask what's f of 10. Let's be faster. Go ahead and tell me what is f of 10. What do you think it is? Well, we double and then add a 3 to it. So 2 times 10 plus 3. And that is, of course, 23. Let's try one more. F of 15. What's f of 15? Well, we learned double that, so 30. And then another 3, so it is 33. Our input can be any number depending on the situation that we have. I could ask what is f of 0, for example. Twice 0 plus 3, that's just 3. I can have a negative input. As we said here, our x and y's are just numbers. We are not dealing with anything necessarily meaningful. So it's not, in the case of a teacher, of course, we cannot have a negative number of years of experience, and such doesn't make sense. But in mathematics, typically there's no restriction as to what x and other variables indicate, and unless they say so explicitly. So I could say 2 times. Now we have a bit of a problem with a negative number. To avoid confusion, I put it in the parentheses so that things are clearer. So 2 times minus 1 is minus 2, and then plus 3, that makes 1. Let's do another negative example. What's f of minus 10? So twice minus 10 plus 3. So we do that one first. That's minus 20 plus 3. So that's going to be minus, of course, 17. Okay, so that was an example of a function. Now let's take another example, a little bit more substantial. Now I write again, y is equal to f of x. Okay, so this is entirely new story. So the name could be similar to something you have seen before, but here's a new function. Let's say 2x squared plus 3x plus 1. So again, we have something here is called the input, name of the input. This is the output. This is the name of the activity we are after. So f is the name of what you see here. What is it that you see here? If an input comes in, what do? We square it and double it, triple it, and then add those two and add a 1 to it at the end to be all done. So we are doing quite a bit of things. An x comes in, you square it, get that and double it, and keep that in one spot. Take the input again and triple it, keep that in one spot, and then add a additional number. Take all these three quantities and add them to each other, and that's going to be your function. Let's go ahead, practice. What does this mean? So suppose I ask, what's f of 5 again? 2 times 5 squared plus 3 times 5 plus 1. Now, order of operation becomes important. When we have all of these things to do, what is it that we do first, and what do? We do second, and so on. So for example, what happens here when we write 2 times 5 squared? We could misunderstand this one as well. What happens is that I double 5 and then square at the end, or is that I square the 5 and then double that later? So the order of operation says exponentiation beats multiplication. So I take 5 and square it, because that's what I've written here, 5 and square it, and then multiply by 2. So that is going to be 5 squared is going to be 25 times 2, and that's going to give me 50. How about here? Well, 3 times 5, that's easy, 15. And then I have an additional 1, and then I'm supposed to add these things to each other, so it's 66. Okay, so here, main source of confusion here would be order of operation. When we write these mathematical formulas, what is it that's going to happen? So these multiplications is one group, here's another group, and this one is by itself. In this multiplication, there is still another activity, which is this exponentiation. Exponentiation has priority over this multiplication. So we do 5 squared first, multiply by 2, 3 and times 5, that is another portion, and the 1 is 66. Let's do another one. So you say f of 3. So what is that? 2 times 3 squared plus 3 times 3 plus 1. So we learned square first, times 2. 3 squared is 9, times 2 is 18. 3 times 3 is 9, and a 1 is 27, and 1 is 28. How about 0? What's f of 0? Well, 2 times 0 squared plus 3 times 0 plus 1. So I'll have 2 times 0. 0 squared is 0 times 0, it's just 0. Double that is 0. This one is 0. And that one makes 1. Let's try minus something as an input. I say minus 5. Again, in order not to get confused and not have things run over, it's preferred to keep the number as you see it here with the wrapper around it, with the parentheses that are around it. So 2 times, I write minus 5 squared, 3 times minus 5 plus 1. If we do something else and you're not experienced, we are likely to make a mistake. So if the number that's given to you is a bit unusual, if it is a fraction, is a negative number, a radical number, or something like that, it's better to keep it inside some parentheses so that the later operation that you do would not be confusing. So minus 5 squared, What's that? What does it mean to write minus? What does it mean to write x squared anyway? It means x times another x. So minus 5 squared means minus 5 times another minus 5. Minus times minus is plus, and I get my 25 back. So this is as before, 2 times 25, so that becomes 50. Here, the minus sticks, it doesn't evaporate like over here. So it's minus 15, and then plus 1. So 50 minus 15, 35, and 1 is 36. Now, let's up the ante here. What if I were to ask what is f of a plus b? Well, let me start with something a little bit easier first. Look, what is f of just a? But the formula that we have here is giving us a recipe what to do with the input. It says you take your input, square it, times 2, times 3, and add them up. Now if your input instead of letter x is some other letter, so you just carry the same thing all the way on the right hand side. So if instead of x I have a, well, it's twice a squared plus 3 times a plus 1, and so on. So in this case, it is not much of a surprise that this is 2a squared plus 3a plus 1. Let's practice this thing. F of b, what is that? Well, same as before, 2b squared plus 3b plus 1. The confusion that I mentioned at the very beginning of the lecture has to do with the following. If I were to ask you what is f of a plus b, what would you say it is? Okay, that is where the challenge of this section is this. What is f of a plus b? Something you learned at the beginning of middle school that comes back to your mind, and that one kind of tells you what the answer is, and that's the incorrect answer. So here what we are facing is what we faced here. If I see that, what does that mean? Is that the LOL, or is that somebody drowning? That is the challenge here, that what we are facing here, first time that you look at this thing, you are going to have a bit of an issue. So remember that the function notation is something very new. It's not that middle school stuff. The function notation was developed several centuries after the previous notations had been developed. So it's like, say, your smartphone compared to your phones that your parents grew up with. There's a different creature. So let me go back and first answer this and then explain where is the source of your confusion. She said f of x is twice x squared plus 3x plus 1. As we noticed here, you said if anytime you are looking at something that looks a little bit different, like negative number, fraction, or something, you're better off putting it in a parentheses to avoid any mistake. So here I even go ahead and put the parentheses that I have on the left. I'm going to put the same thing on the right too, even though not really necessary. So emphasizing that whatever was handed to us, whatever it was, has to be squared, has to be tripled, and all these things have to be added to each other. So we do the same thing here. To emphasize that, let me go color it. So here I have x. I took that x with its parentheses and carried the parentheses with me just for training myself in order how to think about this thing. So I'm going to do the same thing with all functions. So if I have something complicated, negative, fraction, some operations getting out, I'm going to take that box that input with its wrapper. Once square it, another time just write it, and then say I'm going to take twice the input squared plus 3 times the input plus 1. Okay, so the challenge here is what we did here. F of a plus b means, if you want to carry out this operation, it means take your input. So we are put our input in red so that we don't lose it. Take your input, square it. That's what it says. Take your input and square it. Take your input and triple it. And take 1 and add them all to each other. Okay. Well, after that comes whatever you remember from your middle school. Hopefully you remember what was a plus b squared. By foiling or by some other means, this was a squared plus, what was it? 2ab plus b squared. Is that right? You remember that? So this is going to be twice a squared plus 2ab plus b squared plus 3 times a plus b plus 1. Then you might remove the parentheses. It becomes 2a squared, 4ab, 2b squared, 3a, 3b, and a 1. Okay, so that's what it is. What is it that you're likely to think again from middle school? The likely thing for you to do is that you might think adding these two, like this was my f of a, this was my f of b. F of a plus b means add these two. No, that's not what it means. And that you gotta practice this thing often enough to overcome that situation, that thinking, and think about this thing in this context. Let's go ahead, do another practice. Suppose I ask you what is f of, say, c plus, what number is good? C plus 6. So again, we emphasize that take your input and wrap it, or just take it with its wrapper. So it's like you're taking some stuff that you want to ship to somebody, you put it in a box, and then you wrap it very good so that your stuff doesn't spill over with the next person's stuff. And his idea of in the function is the same way. So whatever I have in the input, I say, okay, let's wrap all of that, c plus 6, let's keep it inside its wrapper, square it 3 times that quantity plus 1. Then I can open this thing as before. What is c plus 6 squared? Well, it's c squared twice the first and second, just like what we learned here. So that is 12c, and 6 squared is 36. And then the other one, 3 times 6, c plus 6 plus 1. And we maybe clean up 2c squared, 24c, 72, 3c, say 18, and 1. This seems to be a bit cleanable. So 2c squared, 24c, and 3c. I'll collect similar terms, 27c, plus all these numbers, 72 and 18. What's that? 80 and 90 and 1. So it became 91. Okay, now that we practiced this so many versions, let me say what is the source of confusion in your mind. Back in elementary school or in middle school, you practice the following: a number, followed by parentheses, followed by 2 other numbers added to each other. What did you understand here? you would have understood this is a times. So here, what you had in middle school, this was times a times b plus c. And then you say, well, a times b plus a times c. That was your distributive law. We are dealing with entirely different thing here. We are saying f of. We are not saying multiply f by something. We are saying f of. And what was f? F was the name of a function. So when you are saying, for example, when you are saying salary of a teacher, you are not saying multiply s by 10. You are telling yourself s is a placeholder for the word salary. Okay, so s is not in number there. S is some column on some information or Excel sheet that you're looking at. For example, you're looking at the salary of a person. So the input is some number for years of experience. That one is the particular data that you're looking for. In mathematics, you have to be careful. This symbol f of a plus b and this other symbol a times b plus c, these two are very similar to each other. So you're facing the following situation. Is that LOL? Is that a drowning person? So let me write here. So if I write this, you are rightfully confused as to, well, what is this thing? Is this f times a plus b, or is that f of a plus b? These are entirely different things, but they look mightily like each other. To reduce that confusion, sometimes in my introductory classes, I put back the missing notation so that we don't get confused as to what this is. So this can be read one of two ways. In middle school, this was f times a plus b. In more advanced mathematics, this is f of. Now people don't put the O there, but f of, just to remind you, f of a plus b. So this one is a number that's multiplying that parentheses, and this is the name of a function that acts on the sum of these two numbers. So of indicates to us that we are acting on something, we are doing something, and for which we have a recipe. We are taking that a plus b and we plug it in there and we do that. So generally, from the context, you have to be aware as to which one of these two is meant. Okay, pretty much no book puts either of these two for you. They just expect you to know, just like your phone manufacturer expects you to know that if you press this button and that other button, then such and such is going to happen, and then you just quickly go ahead and learn it because your friends, all of them know it, and you better know it too. In mathematics, it's the same way. If you want to do mathematics, you have to be able to tell the difference between these two from looking at the context that you're working with. Let's go ahead and practice some other examples. So suppose let's use another set of letters. So suppose I say M is h of q, and that is q plus q squared. So we might say here, just to make it clear, let's consider function h. So we are giving a heads up warning that h is the name of a function. So when we say h followed by parentheses with say q inside the parentheses, then we are going to read this thing as h of q. Not h times q, but h of q. So what's the meaning of h of q? The meaning of it is whatever you see on the right hand side. This is the name of a function that is telling you take your input and add to it the square of the input. Let's practice to make sure we understand what this is. Suppose I ask what is h of 5. The recipe says take your input as it is. If you want to wrap it in parentheses, be my guest. Always safe to do that. Always safe to wrap it in parentheses. Then do whatever arithmetic you need to do here. So 5 squared is 25, another 5. So 5 and 25 is 30. How about h of minus 5? H of minus 5, again, safe idea is to take your input with its wrapper and play with that. So minus 5. Well, minus 5 is just minus 5. What is minus 5 squared? Again, we said minus anything squared means multiply by itself. So if you have minus 5 and you are squaring it, it is that times itself. So the minuses cancel and get 25. So it's plus 25. And when you do this subtraction, you get 20. Okay, so that was this is a big step in your background in mathematics. This is going to be a big step differentiating between a situation where a function is involved versus where a number is involved. These are entirely different things. Unfortunately, everything in mathematics is shown by just one letter, and so everything looks like everything else. In most areas in application, they use full words or at least some abbreviation that gives you a heads up warning. Not so in mathematics. So if I write AVE, a mathematician looking at this thing is going to think that you're taking A, multiplying by V, and then multiplying by E. But a person more reasonable than me is likely to think this is abbreviation for the word average. So in many areas, people use abbreviated words, sometimes even full words, so that people don't get confused as to what is meant by a jargon that's being used. But you cannot count on that, especially in mathematics. Things are very condensed and they can be misread. So is this A times V times E, or is it abbreviation for a very common word? Is it average, or is that something else? So you have to be careful about this thing too. Now, one level higher up, suppose I have a function f of x. We give some recipe for, let's say 2x plus 3. And say I have another function. Typically when you have two functions, letters f and g get to be used. Again, tradition in mathematics, just entirely issue of customs. Suppose this is x squared minus 1. Now functions, just like numbers, can be added, subtracted, multiplied, divided, and so on. So for example, I might, for example, in the context of this example we had with the teacher salaries, suppose we give some or extra work or bonus, so we might have a bonus, and after 10 years maybe that bonus is $2,000. Then we can talk about the salary plus bonus, whatever it is. So functions can be added to each other mathematically. They can be added, multiplied, subtracted, divided. In an application, it might not make sense to do all of these things. Perhaps only a few of these things, like S minus B, would be like causing people to go into rebellion. You're subtracting something from their salaries. They would not be welcoming that. But mathematically speaking, we are just playing with numbers. So if I have if I have two functions, I can always think about adding them. F plus G. What does that mean? Well, this is very easy. F plus G means that it's a function that when you apply to x, it's just whatever you had for f of x and whatever you had for g of x, and you are just adding them. Like a salary after 10 years plus some summer pay bonus after 10 years, you add them to each other. It's the same x. It's like we're saying after 10 years of working, you're getting this as a salary, you're getting that as a bonus, and so on. And here, of course, f minus g would mean f of x minus g of x. So what are the formulas for these things? You just take whatever formula you had and do the operation that you want to do. So f of x was 2x plus 3. G of x, so this is the first one. G of x is x squared minus 1. And then you perhaps clean it up. X squared plus 2x plus 2. This one is 2x plus 3. When you are doing subtraction, again, it is a safe thing to take your second item, put it in a wrapper, so you don't make a sign mistake. So when you're doing subtraction, the item being subtracted better go inside the parentheses to avoid some common mistakes. So 2x plus 3 is negative in front of the parentheses, then well, you have to distribute it, and then let's write them in order. Minus x squared plus 2x, and then 3 and 1 is a 4. In the same way, you can talk about f times x or f divided by x and so on. Okay, so what we talked about today was the function notation. We emphasized that it looks like the previous math that you had, but it's entirely new game, and we have to be on the defensive about it, because something that we are so familiar with all of a sudden is having entirely new meaning. And so in the context of these examples, we showed f of x. F is the name of a recipe, x is the input, and the recipe is given by some formula for us which tells us how to play with the input. We said when the input gets complicated, like in these cases, it's best to wrap it in a parentheses and carry it with you like that during the substitution to avoid some common mistakes. So we brought the issue to this issue from middle school versus now, that a letter followed by a parentheses in middle school meant multiplication. So this is how it was in middle school. That is still, of course, whatever you learn in middle school is still correct. Now there is a new kid in town, and it is from the context that you should be able to tell which one of these two are meant. Okay, so if the multiplication sign is missing, this of sign is missing, multiplication sign is missing, so that's where the confusion is. Okay, hopefully I clarified the issue for you. If you have any questions, don't hesitate to bring it up. We can always talk about these things in person. Until next time, Good luck and God bless.